Hello, functions. Okay, so if you missed class, we started with this warm-up. So make sure you hit pause and let's do this warm-up together. Okay, so what is that at the entry of P32? That means third row, 1, 2, 3, second column, 1, 2, so 5.25, and it represents the cost of a 9-inch tuna sandwich. Okay, what is the address of 595? Well, that is right here. So that is in row 1, column 2. So lowercase p, because remember an address is always lowercase. This is supposed to be lowercase. Address, lowercase. Okay, lowercase p, 1, 2. Now if it's a letter like P or C or Z or S or something like that, I'm going to assume that you're giving me a lowercase. All right, we had some definitions today. So a square matrix is a matrix that has the same number of rows as columns. So that's this right here. You don't necessarily need a picture, but this is just an information. So go ahead and hit pause if you needed that. Also, I would put these two things in so that a matrix with just one row is called a row matrix. One with just one column is a column matrix. So, and then that would look like this. So a row matrix would be X, Y, like that. A column matrix would be A, B, C. So just one column like that. Oh, look, my face is in the way. Okay, two matrices are equal if they are in the same size, and then their corresponding elements position by position are equal. So we're going to use that to help us solve later on right here. So if I were to solve, I would want to find what x equals. And so that means that in row 1, column 1, these two things must be the same. Row 1, column 1, row 1, column 1. That would be true for this one right there. And so then this would want to match with this one. And then these match. That's a trapezoid. Okay? So we would want to do it that way. So when we look at that, then we get x is equal to 2, y is equal to 1, p is equal to -1, and q is equal to 0. This one can't be true because, again, we said they had to be the same size. So this is a 2 by 1, and this would be, oops, go back. This would be a 3 by 1. So not the same size, can't be this, we can't say that they're equal. Okay, scalar multiplication, the thing that you're going to want to write in your notes is in red. I'm going to show you a picture of this, so go ahead and hit pause and write down the red. So this is what that looks like. So you're going to see it this way. So it'll say C times A. So that's what this is right here. And then everything inside of the matrix, you're going to multiply that by C. So for this one, we're going to find 3A. So then that means, so we write our answer, we're going to say 3A is equal to, and then I'm going to multiply everything inside this matrix by 3. It's going to take me a minute to write all of this. Okay, so when I do that, I end up with 6, 6, 12, -9, 0, -3, 6, 3, 6. And notice with scalar multiplication, while everything inside the matrix changed, the size of the matrix stayed the same. This was a 3 by 3. This answer, 3 by 3. So that still stays the same. Okay, so now we have something. So a scalar can look that way. It can be like given to you that way, or it can look like this. It can be just directly in front of the matrix, meaning that you need to apply it. So what you would do is you would take that 3/4, and we're going to multiply that 3/4 by everything that's inside the matrix. And since we don't have a name of the matrix, we would just say it's equal to this. So if you're given a name, you can do that. Really, we're going to use this in a problem, so you won't be writing stuff like 3A equals. We will eventually get to that, but it'll be like the name of the matrix. So, okay. So then we are going to add and subtract matrices. So they have to be the same size. So two matrices have to be the same size in order to add them. So that is the most important thing. They must be the same size. And if they are, then those corresponding positions in the elements, that's what we'll be adding or subtracting. If we're subtracting matrices, they also must be the same size. But what we're going to do, so if we have A minus B, then what we're going to do is we're going to say that this is really A plus negative B, meaning that we're going to multiply everything in that second matrix by -1. So first let's do addition. Let's see, do I have all the work? No. So if I was doing addition, what you're going to do is do 5, so this one, plus this one. So that's how I got this first part. And then notice that this one plus this one goes right here. So row 1, column 2, row 1, column 2. Then this 8 and this 8 go together right here. And then this one right here and this one right here. So 9 plus -3, that is right here. So when we do that, then we actually do the work, and that gives us my answer. So this is the answer matrix. Now for subtraction, the thing that we're going to do is, so I'm going to show you the work because I don't like the way that it's typed out over there. So I'm going to show you the work. The first thing I'm going to do is I'm going to rewrite this. So I'm going to write 8, 6, and -4. Now I know that this seems redundant with just numbers, but when we start doing things with polynomials and adding and subtracting and combining like terms, it's going to make more sense. I'm going to turn this into a plus. So remember back here I said we're going to turn it into a plus and negative. Oops. Plus, and then I'm going to do -1 times 3, 5, and -8. So that's what I'm going to do there. So there's the plus, plus, negative. So then I need to figure out what's inside that element. So this then stays the same, 8, 6, -4. Plus, -1 times 3 is -3. -1 times 5 is -5. And -1 times -8 is a positive 8. And then I'm going to add the corresponding things. So my first answer would be 8 plus, so then I'm going to 8 plus -3. Then I'm going to get 6 plus -5. And then I'm going to have -4 plus 8. And then I'm just going to simplify that down. So I end up with 5, 1, and 4, and that is my final answer. Okay, so if you have any questions, please let me know. But that is adding and subtracting. We did this exit ticket in class. So if you would like to try that and you want to check your answers with me, you can go ahead and do that. But this was the exit ticket that we did just for me to check. The thing that I would say is the dimensions of this is 1, 2, 3 rows. So a 3 by 1, 2, 3, 4 columns. So that would be a 3 by 4. So be careful that we're writing that way. Finding entry at M32. So third row, second column. Well, that's 11. And then what are the entries that appear where it's 0? So the first one is right here. So row 1, column 4. So that would be M, row 1, column 4. Notice that this is a subscript. And we are going to have row 2, column 3. So 2, 3. Again, subscript. And then to find 3M, I would multiply everything in that matrix by 3. So I get 6, 3, 15, 0, 3, 15, 0, 27, 6, 33. Whoops, I wrote that in the wrong spot. 12, and 36. And then I need to make sure that I go like this, and then I'm going to be lazy and just do that. Okay, so if you have any questions, please let me know. Otherwise, I will see you another day.